You're looking at a map depicting the extent of the Laurentide ice sheet in North America during the last major ice age. And what we want to talk about in this series of videos is what has been the record of glaciations on planet Earth, not just here in the United States, but elsewhere on the planet. And then we also want to look at how do we actually study and know about past history of glaciations? What evidence is out there that allows us to actually determine the extent and the magnitude of glaciations? And then the final question that we're going to take a look at is what causes ice age? What factors need to come together to cause an ice age like we experienced in North America approximately 10,000 years ago? Okay, the image that you're looking at on the screen is the geologic timescale, and the geology students are probably very well experienced using and interpreting the geologic timescale. If you're not a geology student, you've probably seen it less. What it does is it organizes geologic time into a series of periods, and that's what you're seeing as the named items on this timescale. So on the very far left is time or age in millions of years, going all the way from the present at the top to the oldest time periods in Earth's history on the bottom. And each particular interval is named according to an area or a region where it was, where it's best represented or best exposed. And all of the major intervals are based primarily on fossil evidence and changes in life over time. Okay, I don't expect you to know the geologic timescale for this class, but we are going to talk about a couple key specific intervals of time that are important to understanding glaciations and ice ages. First off, what I want to do is take a look at how global temperature has changed over geologic time. The areas highlighted in blue are time periods when Earth's temperature was colder than the average temperature, and the areas shaded in pink are time periods where the Earth's temperature, global temperature, was warmer than average. And you can see that the Earth has gone through several major cold periods, approximately 5 to be specific. They've lasted for varying amounts of time, some of them shorter, some of them longer, and the most recent period that we're in, the Quaternary, is in fact the last major ice age, and we're going to be talking about that one most extensively. A glacial represents a period of time of colder temperatures where we can have glaciations. An interglacial represents an interval of time where we have warmer temperatures. So those are the two terms that we're going to use, glacial and interglacial. We're going to focus specifically on the Quaternary, and the first thing that we're going to actually talk about is the time interval for the Quaternary. On this particular geologic timescale, it's listed as 1.6 million years ago to present, and there's actually been quite a bit of debate and controversy about that age assignment. In fact, in 2009, there was a series of articles that were published on redefining the age of the Quaternary based on stratigraphy, based on evidence that geologists had uncovered. There was enough evidence to warrant assigning the start date to 2.6 million years rather than 1.6 million years. So the Quaternary period is the last major ice age. This is the only time period I'm going to have you know by name. And I'm going to have you know the age of this time period as well, because it is significant to our glacial history in the upper Midwest. So we're going to be talking about the Quaternary, and you're going to see that word over and over, so you might as well become familiar with it now. So Quaternary started 2.6 million years ago to present. You're still probably going to see the much younger date listed on maps. It hasn't been updated yet on every single map that's out there. The Quaternary glaciation was a great glaciation. There was a tremendous amount of ice that covered the planet. Ice sheets were present on Antarctica and Greenland. Those are the two areas where we currently have ice today. There was also the Laurentide ice sheet, which was the ice sheet that impacted our area in the upper Midwest and covered a great part of Canada. There's also the Cordilleran ice sheet, which is found in the the very far western part of Canada, and then the Scandinavian ice sheets, and Siberian, which were impacting the northern parts of Europe. So North America, the Laurentide accounts for the majority of the U.S. and Canada in the east. The Quaternary was primarily the Rocky Mountains and Alaska in the west. Why are they separated? If you notice, there's actually a dotted line on this diagram. The reason that they're separated is that's the Great Continental Divide. So just like fluvial processes work on the scale of watershed divides and drainage divides, ice buildup and glaciations work in the same way. Was the Quaternary the greatest ice age on planet Earth? It actually wasn't. If we go back to the Proterozoic or in the Precambrian, there was a very large, very extensive glacial ice period that was known as Snowball Earth. It occurred approximately 650 million years before present. The entire Earth was frozen or nearly frozen. We might actually get a chance to read some articles about this by the time we get done studying our unit on glaciers. The evidence for this particular glaciation, we found basically glacial sediments in the tropics, which is a good indication that the entire Earth was covered in glacial ice. The time period is affectionately known as Snowball Earth. This is the article. If we get a chance to read it, it's kind of an interesting read and looks at the evidence and sort of what happened on Earth during this time period.